premise is you separate your variables, then you integrate both sides, you solve for c, and then you solve for y. That's pretty much what we're doing. Now, this kind of question, Yuchin, I need you to put that away. This kind of question has been on every ACT test that every AP test that I've ever seen. Watch, this will be the year they're going to make a liar out of me. But it's on there all the time. And it's one of the very rare instances where you get no credit if you don't do the first line right. Okay? Generally speaking, on the AP test, if you don't understand how to get the equation, but you come up with something, you take your best shot at it, right? You make a legitimate try at it. You just don't pull something out of left field and then they go, yeah, no, I don't think so. Okay, but you make a legitimate try at it, you come up with the best equation you can, and you run with it. It's called reading with the writer. And I've been told by people who've been to the AP reading, when they actually grade these tests, that on the chalkboards going around the room, they'll have, okay, if the student started with this, this is what it should look like. If they started with this, this is what it should look like. So if you have the wrong start, and it's a legitimate wrong start, and there can be many, wrong starts, but if you get everything after that correct, you can pull some points out of it, okay? So the whole idea is to get as many points as you can, right? You're shooting for 108, and you want to get as close to that number as you can. So wherever you can get a point, you want to take a point, right? So you don't look at a question and go, I have no idea. Don't know how to start it, just not even going to go there. You do something, okay? Notice the signs. You do something, right? Put your pencil to the paper, you put something down, and you run with it, okay? Take your best shot. So this is one of the rare instances, however, that if you don't separate the variables, you've got no chance, and generally speaking, these are 5 to 7 points. So this is where you don't want to take it for granted and just let it go. So what I'd like to do is go through some examples of some that are a little bit more complicated and different looking than the ones we've done so far, just to get us in the idea of this. By the way, this technique was first used in 1960, which when you consider that calculus has been around since the early 1700s, is a very relatively new phenomena. It was discovered by James Bernoulli, and he was solving problems that had to do with pendulums at the time. A little fun fact now and tell. Okay, so let's take the differential equation, dy dx. Am I on the screen? Okay. dy dx is equal to 6x squared over 2y plus cosine y. Now, the basic premise is you have to be able to separate the variables. Can we in this problem? Yeah. So what we'll do is get the y terms on the left side, so we'll multiply each side by this y term. And we will get the x terms on the right side. And once that happens, we can take the integral of each side. So separate your variables, take the integral. On the left side, what are we going to have?
Y squared plus y.
Okay. And on the right side, what are we going to have?
2x cubed plus...
Now technically there's a c on each side, correct? There should be a plus c on the left and there should be a plus c on the right. But we'll take this c, we'll subtract it from both sides, and we're only going to carry one c through the problem. So a c added or subtracted from a c is still just a c. Okay? So we're only going to write it on the x side. Because eventually we're going to solve for y anyway if we can, and so we want to put it over there. Okay. Let's say we know that the initial condition y of 1 is equal to pi. Can we find c? Okay. So we're going to have a pi squared plus the sine of pi equals 2 plus c. Or, what is the sine of pi? 0 is right. So we'll have pi squared minus 2, which tells my equation is y squared plus sine y equals 2x cubed plus pi squared minus 2. Now, if you can solve for y, you would want to solve for y. Is it possible to solve this explicitly for y? No. So then we know we're done. Questions on that one? Okay. Let's say we are given y prime equaling x squared y. Okay, how do you separate a y prime?
It's just dy.
That's right, rewrite it. So instead of using Newton's way of writing it, we're going to turn it into Leibniz's way of writing it. And once we have it written this way, now we can separate it. So we have dy over y equals x squared dx. When you integrate each side, we'll have our ln of absolute value of y equals 1/3 x cubed plus c. Can this be solved implicitly? Or explicitly, rather? Okay, then we're going to do it. So e on both sides. So y is going to equal c e to the 1/3 x cubed. Now, how are we going to deal with that absolute value? Because that absolute value didn't go away, right? That's still the absolute value of y. So if I want to solve this for y, what would I have to realize?
Plus or minus.
That's right, it's going to be a plus or minus, and that plus or minus will be dependent on what the initial condition is. If the initial condition is something that's going to be a negative, then it's going to be the negative. If the initial condition is going to give us something that's a positive, then it's going to be the positive. Okay? So this plus or minus will be dependent on the initial condition. And that generally is something that will be in your problem. Okay? It'll give you a domain. Okay? Let's say we have x squared plus 4 dy equaling, or dy dx rather, equaling xy. Now what are you going to do?
X divided by x squared plus 4 and dx and divided by y.
Yeah, divide that, and over here we're going to divide this and move our dx over. Is everybody okay with the separation step? Okay, now when we integrate, what are we going to do? Left side is,
ln of 1
and the right side,
is u equals x squared
yep,
plus 4.
little u stuff. So u would be the x squared plus 4, du is going to be 2x dx, 1/2 du would be the x dx. So we're going to have the integral of 1 over u du times that 1/2. So we'll have the ln of the absolute value of y equaling 1/2 ln absolute value of u plus c, or the ln of the absolute value of y would be 1/2 the ln of the absolute value of x squared plus 4 plus c. Is this something you can solve explicitly for y?
Yes.
Okay. So the absolute value of y would equal c e to the 1/2 ln absolute value of x squared plus 4. Is there another way I can write this right side? This exponent thing. Is there another way to write that?
Make x squared plus 4 to the 1/2 power.
Right, and if I make this to the 1/2 power, that would be the same thing as a square root, would it not? And do I have to worry about the absolute values if I put it as a square root?
No.
No, because you can only take the square root of a positive anyway, so that absolute valueness is not going to be an issue. And because I want to get rid of these absolute value bars, I know it's going to be a plus or minus depending on what the initial condition or the domain is. Okay? What about dy dx equals 0.056y, given that y of 0 is 100? See what you can do with it. Are we ready? Or do you need another 30 seconds? Looks like most pencils are stopping. Did you get this? Y of x or y of t equals 100 e to the 0.056t. So we're okay? Awesome. What about this one? Try that.
No initial condition for this one?
Nope, not for this one. Did you get this?
The C would be on the.
C would have to be under the radical. It makes a difference. It does have to go under the radical. Is everybody okay with that? Any questions? All right, then let's take the gold sheet that you picked up. And let's start on the side that says the slope of the tangent line to a curve at any point x, y, and the curve is equal to 3x squared y squared. Find the equation of the curve if it contains the point 2, 1. Okay, so if you see something like this, what do you think we should start with?
dy dx.
Right, because it says the slope of the tangent line, right? Well, slope is the derivative. So the slope would be the dy dx equals 3x squared y squared. And we would separate our variables. So we're going to have dy over y squared equals 3x squared dx. Once they're separated, do the integral. And what's the left side going to be?
Negative y to the negative 1.
Very good. This is the thing that people get wrong the very most. Is everybody okay with that? It looks so simple, but for some reason it just sticks in people's brains wrong. So hopefully we're okay there. Equals x cubed plus c. We do have an initial value at 2, 1. So we're going to have negative 1 is equal to 8 plus c. c is negative 9. So we have negative y to the negative 1, which is 1 over y, equals x cubed minus 9. I would like to solve this for y if possible, and it is possible. Y is going to equal negative 1 over x cubed minus 9. Is everybody okay with that transformation? Okay. Business firm made an analysis of its production facilities, its personnel, with the present equipment and number of workers. The firm can produce 3,000 units per day. It was estimated that without any change in investment, the rate of change of the number of units produced per day with respect to a change in the number of additional workers is 80 minus 6x to the 1/2, where x is the number of additional workers. Finally, daily production of 25 workers are added to the labor force. Okay, I'll give you a minute. Figure out, what is this telling you? Read between the lines. What do we know? Which words in here are going to tip us off? Take a stab. Talk to the person next to you. See if you can find the words in here that are going to be our clue.
This is rate of change with respect to this equation. Then x is an additional number, so that means that 0 is 3,000, and then 25 is what we're trying to find.
Okay, did you find any words that are going to tip us off? Where?
Rate of change.
Rate of change. That's telling us that's our slope, right? So our rate of change, I'm gonna call it dWd x, because this is in terms of x's, and so the number of workers is gonna change with x. With respect to a change in the number of additional workers, so what is that gonna be?
80 minus 6.
And do we need anything else besides that? Yes, no, maybe so? Eventually we're gonna need that, because that's the original amount. When t is equal to 0, the number of workers is 3,000. So we'll use that to help us figure out our initial condition.
How would you get T?
Pardon? Where did we get?
T?
Up here. I guess it's x if you wanna, let's see. When x equals 0, w equals 3,000. I just always put t's down, I guess, because I'm so in a habit of doing that. Does that help?
Yeah.
Okay. So let's separate our variables. dw is going to equal 80 minus 6x to the 1/2 dx. Integrate both sides. W will equal 80x minus 6 times, this is going to be an x to the 3/2, so we're going to have to multiply by 2/3 plus some constant. So w equals 80x minus 4x to the 3/2 plus c. We need to figure out what our constant is. If we put zeros in for x, our constant is going to be the 3,000. So w equals 80x minus 4x to the 3/2 plus 3,000. Okay with that? So what if we're going to add 25 workers? You would put 25s in here, so we're going to have 80 times 25, which is 2,000, minus 25 to the 3/2. Square root of 25 is 5, 5 cubed is 125, 125 times 4 is 500, plus 3,000 equals 4,500 units. Questions? Are we okay there? All right, flip it over. Right circular cylinder tank has a radius of 5 feet and a height of 16 feet. First thing my brain does is want to draw a picture so I can see what's happening here. So we have a radius of 5 feet and we have a height of 16 feet. That was initially full of water. It's being drained. We're leaking again. At a rate of 0.5 square root of x cubic feet per minute, find the formula for the depth and the amount of water in the tank at any time t. How long will it take the tank to empty? Okay, so what kind of problem do we have here? Can we find the volume of a cylindrical tank?
Yeah.
What would the formula be? Okay. And if we fill in what we know, the radius is not changing, is it? Okay, so that's going to be 25 pi. Is the height changing?
Yes.
Yes, so we cannot put a number in for height. Okay. If I were to take the derivative of this, I'd have dv dt equaling 25 pi dh dt. Sort of looks like a related rates kind of a thing, doesn't it? Okay. Can we calculate any information from this? What do we know here?
dHdt is 0.5.
What's the 0.5?
The rate
The rate that what is changing?
the height,
Volume.
volume.
Right. 2 clues. It says that the water is being drained, so it has to do with the volume of water. Plus, if we look at the units, it's cubic feet per minute, which means it has to be volume and it's cubic feet. So those are the 2 things that would give us hints. So our dv dt is 0.5 square root of x. And so if we substitute that in, can we find the change in height? Okay. So if we solve this, we're going to have each side divided by 25 pi. So we got, this would be a half, and that's 25, so it would be square root of x over 50 pi is our dH dt. here. But what we want to solve for is x. Can we put anything in for dH dt?
0. 16. Because it's going to empty, so.
Do we know how the height is changing?
Can you use?
That's going to be our x. So that's the same as x. So our square root of x over 50 pi, because that's our change, is going to be dx dt. And if we take this integral, we can find the time. Because that's our change. That height is what's changing. So if I wanted to solve this for x, what would I have to do? Separate the variables. So I'm going to have, okay, I have to write it this way just because it's the only way my brain works. Okay, so I'm going to have dx, and I have to divide it by this, which is going to make that h to the negative 1/2, right? Equals 1 over 50 pi times dt. Is everybody okay with that separation? It's a little tricky. Integrate both sides, and what do I have on this side?
Negative 2x to the 1/2. Oh no, 2x.
2x to the 1/2 equals 1 over 50 pi t plus c. Now, did I lose a negative? Oh, back it up, back it up, back it up. I lost a negative. It's draining. So what do we need to do? This has to be negative, right? Because it's draining. All of a sudden I realized I'm missing a negative here somewhere. Okay. So let's see here. So we're going to have what's that? We have to solve this thing for t. If we want to know what happens when it's empty, what can we do? Because we want to know how long it takes for it to empty.
Plug in 0 for x.
0 for x. So C is, did we ever find C?
No, we don't have time either. Oh, we can find C. How do we find C?
5 squared.
When t was 0, what was the height? 16, right? Because it started out full. Okay? So we're going to have to find C. I'm running out of paper here. So if we have, when time is 0, so we have square root of 16 is 4, times negative 2 is negative 8, equals 0 plus C. My negative ended up on the wrong side up here, didn't it? Remember how we said the negative always has to be on the t side? Yeah. So it's positive 8. So my equation is going to be negative 1 over 50 pi t plus 8 equals 2x to the 1/2. When x is 0, we can solve this for t. So 1 over 50 pi t equals 8. T would be, multiply each side by 50 pi, 400 pi minutes. I know it's a weird way to think about minutes, but it works. Is it off the page? Is it on now?
Yeah.
Okay. One little negative can make all the difference in the world. Questions? this page. Stone is thrown vertically upward from the ground with an initial velocity of 128 feet per second. If the only force considered is that attributed to the acceleration of gravity, find out how high the stone will rise and the speed with which it will strike the ground. Also, find out how long it will take for the stone to strike the ground. So essentially, starting at ground level, we're throwing a stone up in the air. If the initial velocity is 128 feet per second, that would be our v of 0, correct? Okay. The only force on it is gravity. What does that tell you? And what would a of t equal?
9.8.
Except that we're in feet. In feet, what would it be?
What's that
30
gonna be?
something.
Negative 32.
Yeah.
Okay. So this would be a of t dt, right? So we're going to have that a of t is equal to negative 32 dt. Integrate each side. Integral of acceleration is velocity. So it'd be negative 32t plus c. We do have an initial velocity of 128. So we can calculate c as 128. So we have v of t is equal to negative 32t plus 128. Now, if we want to know how long it's going to take to hit the ground, we need to know the equation of the trajectory. So what do we need to find?
The vertex.
And that's going to come from the parabola, right? So we're going to need s of t. So how are we going to get that? Integrate. So we're going to dt this, take the integral of each side. Integral of velocity is position. So it'll be negative 16t squared plus 128t plus c. Initially, where was this thing?
Ground level.
Ground level, so this would be a 0. Okay? If we want to know how long it will take to strike the ground, what do we have to do?
Calculate the time.
Calculate the time. The position when it hits the ground will be 0. So 0 would equal negative 16t squared plus 128t. Let's see, does 16 go into 128? Maybe have a calculator on? I think it does. I think it's 8. But somebody check that for me, please.
Yeah.
Okay. So when t is 0 and when t is 8, it's on the ground. So at 0 and at 8, it's on the ground. So how long is it going to take to reach the peak then? 4 seconds. And can we calculate how high it's going to rise? What do we need to do? Plug in 4, right? S of 4. So we would have 4 squared is 16 times negative 16, which is negative 256. And 4 times 128 is 32, 3, 8, 9, 10, 11, 1, 5, 12. So we end up with 256 for our height. Any questions on that? All right. Then, takes care of that one. Oh, this is really stuff that should have been in yesterday's notes. Did that one. Okay, let's take a look at the blue. There was a blue, right? Yeah. Looking at this blue one, we don't have time to do all of them, so what I would like you to do is see if there's one on there that if you saw it, you would have no clue how to start. And then I'm going to give you 1 or 2 that are different in case you don't figure out which ones are weird and wonderful. So looking at them, what do you think?
Number 8.
Number 8? Okay, let's do number 8. How would you separate those variables? You found the worst one on the page, that was a good pick. How would you separate those variables? Because they're added and subtracted. When we separate them, they have to be a product, don't they? In order to separate them, they have to be a product. So how do I turn this into a product? What do you think, Jason? Couldn't hear you.
Minus something times t minus something plus b.
So to turn the right side into a product, factor. Anytime you want to take some terms and turn it into products, you need to do some factoring. So if I look at the first two terms, there's nothing common between those two terms, are there? If I look at the last set of two terms, what's common? X. Let's factor out a negative x, and then it's going to give me a 1 plus t. So that means my dx dt is going to be a 1 plus t times, when I factor out this 1 plus t, there's still a 1 here, right? So it's going to be a 1 minus x. Now that it's a product, now I can split it. Because you can only split a product, you can't split sums and differences. So now I can make this dx over 1 minus x equals the quantity 1 plus t dt. Is everybody okay with that? Now to separate that and integrate it, I will have the ln of the absolute value of 1 minus x equals t plus 1/2 t squared plus c. Okay so far? Exponentiate each side. We'll have 1 minus x equals e to the t times e to the 1/2 t squared plus c. So x is going to equal 1 minus e to the t. Actually, we can split this differently, can't we? We'll put these two together. T plus 1/2 t squared times that e to the c, and pull that out as your c. Does everybody see what I did there? See if I can make it a little bit bigger.
Wouldn't it be a negative, Ellen?
Yes, it would be. Which will make this a negative, which will make this a negative, and this a negative, which is going to make this. Multiply everything by negative, we're back to where we started. So does everybody see how factoring is going to help you on that? Okay, looking at this page, what else should we do? What other one looks like would be difficult to split? 7? Okay. 7 is definitely something that has all of the variables in the exponent. So what we need to realize is that e to the u plus 2t is e to the u times e to the 2t. Is everybody okay with that? Now can we split them? Okay, so it'll be du over e to the u equals e to the 2t dt. What happens when we integrate?
The E and the Ellen drop off.
Get the ln of e to the u equals, what on the right side? 1/2 e to the 2t plus c, good. What is this thing on the left equal to? Any questions? Okay, anything else on this page?
Number 12.
Number 12? Looks kind of messy, doesn't it?
Yeah.
You'll notice that there is an x plus. Why did I do that? Oh, we're going to subtract that x from each side. To get it to the other side. And now, can we get it split out? We had to get this out of here because we can't have pluses and minuses. So if you can't factor it out, you've got to add or subtract it to get it to the other side.
So it's a negative x over square root.
So there's a negative x on the right side. And now when we split our variables, we're going to have a 2y dy equaling a negative x over the square root of x squared plus 1 dx. Okay with that? Okay? Are we ready to integrate? Have we split it all right? So on the left side, we're going to have a y squared, and on the right side, what do we have to do?
U substitution.
That's right, so up here, do my u's. I'm going to be x squared plus 1 for my u. du is going to be 2x dx. So 1/2 du is going to be the x dx. So I'm going to have and I'm going to pull this negative out, so it'll be negative 1/2 of the integral of u to the negative 1/2 du. So y squared is going to equal negative 1/2. This is going to be a 2u to the 1/2 plus c. So I have negative square root x squared plus 1 plus c. Looks like we have an initial condition. The initial condition is y of 0 equals 1. So 1 will equal the negative square root of 1, which is 1. So c is going to equal 2. So y squared would equal negative square root of x squared plus 1 plus 2. I would probably not solve this for y because I have a square root with a square root. We are going to have some domain issues here though, aren't we? Because when you think about it, if you did your square root, you'd end up with this. This thing under here would have to be positive, so there's going to be a limited amount of things that x could be. So we're going to have a very limited domain. Because this is going to have to be smaller than 2. Right? So this is only going to work for a very limited number of values. Okay, let's turn the paper over to the other side. Anything you see on that side that we should look at? That you would wonder, how in the world would I do this?
Number 9 is an x, y minus ln(x).
Right, what I would do here because of that minus is I would first of all add that ln of x to each side. Okay, now we don't have any pluses or minuses anymore in the problem. Now we can split it, so we would have, leave the y over here. We're going to divide each side by the x and move over the dx. So that when you integrate the left side, you'll have 1/2 y squared. And on the right side, you're going to use u's, right? What would you let u be?
ln of x.
Right. Because if u is ln of x, then the du is 1 over x dx. So we're going to get a nice, pretty u du. And when you integrate that, you're going to have 1/2 u squared plus c. You can put that c back in, or you can put the ln back in, so it'll be 1/2 ln of x squared plus c. Now when we evaluate, we do know that y of 1 is 0. So this would be 0 equals, and ln of 1 is 0, right? So 0 is c, so we'd have 1/2 y squared equals 1/2 ln of x squared. So y squared is going to be the ln of x squared. Anything else on this page?
Couldn't you take the square root of both of them?
You could, but you would have to state that y would have to be a positive number. Or would it? Yeah, because the ln's are going to have to be positive anyway, so yes. But think for a second. if we could do that. Others that you see? 12? Okay. It's kind of looking a little bit like one of those Newton's law of cooling kind of things. So the first thing we have to do is get rid of this plus, so we're going to have k times, well, let's see here, which side do we want to put things on? I guess we can do it this way. T minus 70 dt is equal to negative dt. So k dt would equal negative 1 over t minus 70 dt. Ooh, that's going to work nice. Okay, so on the left side, when we do our integral, we'll have kt plus c. And on the right side, what are we going to have?
Negative ln.
Except that we have the negative already. So if this were your u, your du would be the negative. So we've already got it, right? So we don't have to worry about the negative. So it's going to be ln absolute value of t minus 70. And we do have an initial condition, so we can find the c. So we're going to put a 0 in for t. So this would be c equaling the ln of 70. Pardon? Because we're going to have 140 minus 70. Are we okay there? Okay. So kt plus ln of 70 would equal the ln of the absolute value of t minus 70. Kt would be the ln of the absolute value of t minus 70 minus the ln of 70. Can we simplify those ln's? Would be the ln of what?
T minus 7 over 70.
And t would be 1 over k ln of 70 minus 70 over 70. So it's a ratio.
Could you move it up here?
Does that help on that one? Okay, Alan, Adam?
Shouldn't the ln be negative, because u is going to be positive, or, yeah.
The T is-
But if you come back up here and you let u be the t minus 70, then du is going to be, oh, yeah. I was thinking of ln of that. But when we do the ln, it's not the t that's negative, it's the number that's negative, you're right. I was thinking it was 70 minus t, which would be different. So you are correct, that would have to be a negative. Which means, I'm really getting messed up with negatives today, aren't I? Which means this thing is a negative, which means this is a negative. So both of those things are going to end up in the denominator, aren't they? Yeah, good call, Adam. So it's going to be the ln of 1 over 70 times t minus 70. Because they're both negative. Negative and negative. Actually, let's just pull out a negative. Make it better yet. Pull out a negative. So kt is negative of ln of t minus 70 plus the ln of 70. That's a better way to write it. Yeah, I was thinking it was the 70 minus t. You're right. Because my brain just went right to Newton's law of cooling, and you always have the negative on the variable. Should not jump to conclusions. All right. Anything else on that page? Yes?
I'm just worried about the negative one.
Where we got what?
The negative.
That negative? Okay, when we go back up to this problem right here, that dt was on the left side. Okay? we needed to get it off to the right side, so we had to subtract it from each side, which made it a negative DT.
Oh.
And that's what started all the problems right there. Right from step one. Okay, then the other papers that you picked up. The tan one is practice with differential equations, separating variables. There is a practice problem on here for graphing your slope field. There's a practice problem on here for sketching in a solution line. The only thing that you are not required to do, these used to only be on the BC test, now they're on the AB test. The only thing you do not do is Euler's method. Euler's method is a BC topic, it is not an AB topic. But the slope field one is something you should be able to do, C you should be able to do, and D you should be able to do. We kind of worked this problem yesterday, but I wanted you to see these so that you can practice with those. And on the other sheet that you picked up,
We had an Euler's method in our homework as well.
what?
Yeah, I had to look in the book for it.
No, skip Euler's method.
Okay, I had no clue.
I thought
how to do
that
it.
one was taken off. We used to do Euler's method, and then because of time, they moved the test up, and we all these days were missing because of assessments and all that kind of thing. So I just decided, it's a BC topic, I'm just not gonna cover it this year. So we're not gonna worry about that. And then here is some practice on matching slope fields, general slope fields, differential equations, particular solutions, and matching the families. Those are all things that you need to be able to do out of this section. Okay? So you have no time, but those are the things you want to be practicing. Monday, I will not be here. There will be a sub here. You will be having some worksheet practice on this. Tuesday will be 6-4. Wednesday and Thursday, we're going to be doing some practicing, and Friday is your test. Any questions? Really could have the test Thursday now that I'm
Is it a one-day test?
It's a one-day test. Any questions? Is everybody good?